We will continue our discussion on IC engine, and today we will continue our discussion on the battery ignition system, and more specifically we will see that what are the procedure or rather what are the step by virtue of which we can have the potential which is of the order of 10 kilovolt to 20 kilovolt to generate a spark in a to break the resistance of a spark gap. As I said that we are having one battery which is having battery of 12 volt to 24 volt. From that low voltage how we can generate high voltage which is of the order of kilovolt 10 kilovolt through this circuit. So, now I will write the steps by virtue of which we can have that higher development of the higher potential. So, this is a schematic we have discussed about the function of each and every parts of the system. We have ignition switch, and then we have resistor and ignition coil and breaker points and distributor rotor. So, today we will discuss that what are the steps of steps by virtue of which we can have higher steps for the development of higher potential. So, this is very important that from that circuit how we can have higher potential, and that is what we will discuss today. So, first step is that is very important, that when the ignition switch and breaker points are closed. So, when ignition switch, that is we have labeled already, and breaker point are closed, then a low voltage current, a low voltage current IP will flow through the primary windings, primary circuit or primary coil, whatever you can give, primary windings, right. So, if I go back to my previous slide, then where schematic is shown, then if when the ignition switch and breaker points are closed, then a current will flow, a low voltage current IP, and that but through the primary winding. So, we are having one primary and secondary winding in the ignition coil. So, this is primary and this is secondary. So, primary winding and secondary we have in a ignition coil. So, when ignition switch and breaker points are closed, a low voltage current will flow through the primary winding, and that is the first step, that is what we are writing. Second, number 2. So, we have understood that when the ignition switch and breaker points are closed, a low current will flow through the primary winding. Second is, when the low current is flowing through the primary winding, it building up a magnetic field around the coil. So, this process building of magnetic field around the coil, and while expanding this magnetic field, while expanding this magnetic field cuts the primary winding. While expanding this magnetic field cuts the primary windings, and induces a back EMF and induces a back EMF, electromotive force, which opposes the battery current, and therefore delays the building process, which opposes the battery current, and therefore delays the building processes, and therefore delays the building processes. So, this is the second step. So, when an ignition switch and breaker points are closed, a low current, low voltage current will pass to the primary winding. While it is passing to the primary winding, it builds up a magnetic field around the coil, and while expanding this magnetic field cuts the primary winding and induces a back EMF, which also opposes the battery current, and therefore delays the building process. Number 3, very important. So, development of the building process of which delays the building processes of the field itself, fine. A voltage is also induced, a voltage is also induced at the secondary winding, at the secondary winding, but the potential, while it is happening, a voltage will develop also in the secondary winding, but the magnitude is too low, but this potential E2 is too low to produce a spark, usually low to produce a spark at the spark plug. So, a voltage is induced at the secondary winding, but the potential is usually low to produce a spark at the spark plug. So, what is spark plug? Because of the relatively slow movement of the magnetic flux, because of the slow movement of the magnetic flux, right. Then 4, very important. Now, when the cam on the distributor rotor, this is the process. So, voltage will be induced definitely, but the magnitude is very low to produce a spark because of the slow movement of the magnetic flux. So, when the cam on the distributor shaft, or rotor opens the contact point, right. The magnetic field that developed, magnetic field about the collapses, magnetic field collapses, and an induced field, an induced current from the collapsing magnetic field, from the collapsing magnetic field flows in the same direction, in the primary circuit, as the battery current, So, when distributor rotor opens up the contact points, a magnetic field collapses. Because of this collapses and collapsing the magnetic field, and induced current also flows in the same direction as the battery current does in the primary circuit, fine. So, now primary circuit, not only that, and charges the condenser, because breaker points are closed. So, it charges the condenser, which acts as a reservoir for the charges the condenser, which acts as a reservoir for the flowing current. Now, very importantly, number 5, due to rapidly collapsing collapsing of the magnetic field, rapidly collapsing of the magnetic field, a high voltage is induced in the primary, a high voltage is induced in the primary, which is of the order of 25 about 250 volts. Primary winding, and even higher in the secondary windings. Secondary winding, even in the higher in the secondary winding, which is of the order of 10 kilovolt to 20 kilovolt. So, due to rapid collapsing of the magnetic field, a high voltage is induced in the primary as well as the secondary, but the strength of the voltage is of the order of 250 volts in the primary, while the voltage is even much more higher, and that is of the order of 10 kilovolt to 20 kilovolt in the secondary windings, right. This high voltage in the number 6, this high voltage in the secondary winding, the high voltage in the secondary winding passes through the distributed rotor, to warm the spark plug, and ignites this and leads to a spark. So, that is very important. Now, this is the procedure by virtue of which we can have spark in the spark plug. So, this process repeats, the system is ready for another firing unit. Now, the induced current in the primary flows in the same, now number 7, very important, the induced current, the induced current in the primary circuit flows in the same direction as it did before the breaker points opens. In the primary windings flows in the same direction as it did before the breaker points open up, before the breaker points opened up, right, and breaker opened up and charges the condenser. Right. So, this is that induced current in the primary winding flows in the same direction as it did before the breaker points opened up and charges the condenser. So, the increasing potential in the now the increasing, because it charges the condenser, the increasing potential of the condenser, the increasing potential of the condenser retards and finally stops the flow of current in the primary circuit. Primary circuit, and then rapidly backfires and rapidly discharges again through the primary, discharges through the primary, but in the opposite direction. Primary winding, but in the opposite direction. That means this induced current in the primary flows in the same direction as the battery current as it did before the breaker points opened up and charges the condenser. So, while it is charging the condenser, the increasing potential of the condenser deters and finally stops the primary the flow of current in the primary circuit, and rather rapidly discharges through the primary winding, but in the opposite direction, and the rapid discharge of the condenser produces this rapid discharge of the condenser produces directional oscillation in the oscillations in the current flow in the primary circuit. In the current flow in the primary circuit. This is very important. So, now these oscillations 8, this oscillation is weakened with every succeeding reversal in the current flow. Until the original potential and the direction of current flow is until the original potential and the direction of current flow in the primary circuit are established. In the primary circuit are established, right. So, now this is happening. Now, the system is ready for the another firing circuit. So, now 9, now the system is ready for the another firing circuit, very important. The entire breakdown process usually takes very small second of the order of 10 power minus 3, 10 power minus 4 second. The breakdown of the spark gap, usually occurs approximately at 0.001 second. So, now what I said that when the switches, if I now try to plot that when the ignition switch and the breaker points are closed, a low voltage current flows into the primary circuit and it builds up a magnetic field, and while expanding this magnetic field cuts the primary windings, as I said as a first step. So, when ignition switches and breaker points are closed, a low voltage current will pass through the primary circuit and it develops a magnetic field. Now, while expanding this magnetic field cuts the primary winding and it induces a back EMF, and that back EMF will opposes the battery current to flow in the primary circuit and delays the building process. So, that is why if I now plot that battery current IP primary windings, then the process gets delayed. Then it is very important, A, B, C breaker points. So, this is A, this point is B and this point is C, and then it rapidly comes to 0, and then again a directional oscillation starts. So, directional oscillation starts. So, this point is D, then E, then F. So, this takes very small time, delta very small time to this delta t is very small. So, A, B, C is the breaker points are closed. Breaker points are closed, that is a low voltage current is flowing to the primary circuit and it will develop a magnetic field, and while expanding it develops, while expanding the magnetic field it cuts the primary winding and induces back EMF which opposes the current flow in the, which opposes the battery current to flow and therefore delays the building process. CDE that is the charging time of the condenser. This is charging time of the condenser, that is what we have discussed, condenser, and EF, this is the discharging of the condenser, discharging of the condenser. So, this discharging and charging, that is what discussed, that it retards when it is charging the condenser, it potentially increase and eventually it retards and finally stops the that is what we have discussed, that finally we have discussed that same direction, and condenser retards, it charges the condenser, the increasing potential of the condenser retards and finally stops the flow of current in the primary circuit and rapidly discharges to the primary winding, but in the opposite direction, and this leads to a directional oscillation, and that is what is represented by this small spike in the current versus time plot. This is T, current versus time plot. Now, with a very small delta t that that is what I told you, that high voltage in the secondary winding passes through the discharge, a rapid collapsing of the magnetic field, a high voltage in the induced winding even develops, and the high voltage in the secondary winding passes through the distributed rotor and warm the spark plug, leads to a spark. The induced current, and in a very small time, that the breaker points are closed, but when breaker points are opened, that IPT will try to be 0 very small time. This means that that when breaker points are opened, the current will try to 0 within very small time, that is why delta t is very small, and then it will try to charge the condenser, and when potential of the condenser will increase, then again it will try to retards and finally stops the current flow, and it leads to a directional oscillations that is represented by the small spike in the current versus time plot. So, we have seen today that although we had a battery of 10 volt to 24 volt, from that battery rather source of electrical energy, we had circuit, and from that circuit we can produce high voltage in the primary, that is of the order of 250 volt, but even more higher in the secondary, that is of the order of 10 kilovolt, and that high voltage leads to that warm up the spark and break the resistance of the spark gap and leads to a spark in the spark plug. So, this is a completely description of the battery ignition system, by virtue of which using a low source of electrical energy we can produce high voltage and we can generate spark and we can ignite the combustion process in the spark ignition engine. So, with this I stop here today and we will continue our discussion in the next class. Thank you.